cruising along here, moving up, going across here, minus the change in, or X plus the change in potential across the 2 ohm resistor has to be equal to 0. I gain, I lose. So the change in the voltage across the resistor, negative delta PS, or negative 12. In other words, when I go across it in this direction, when I go across it that way, I'm going to lose 12 volts. I know delta V equals IR. 12 is equal to I times 2 minus 6. What about the current flowing across the 4 ohm resistor?
3 ampere.
What is the current flowing out of the power supply? Yes. Because when the current flowing out of here splits, I know 6 amps goes that way, 3 amps goes that way. Whatever current I have flowing in has to be the current flowing out. So if I have 9 amperes flowing out of that, I have to have 9 amperes flowing in. Therefore, my equivalent resistance is, I know that voltage is equal to I know I this time, equals 9 delta V is IR times R equivalent. R equivalent is 12 ninths or 4/3. That was the roundabout way of finding the equivalent resistance. If we just did what we had over there, 1 over the equivalent resistance is equal to 1 over 2 plus 1 over 4, which is 3 over 4. The equivalent resistance is 4 over 3. Just doing it the long way. Oh. The faster I write, the worse it's going to look. Now, you're looking at this and going, yeah, this is really exciting. Yeah, I definitely want to find out more, but where are we heading with this? Well, in the shorter term. By the way, this is material for test 1B. This is not for the first test. We'll eventually get to the point. We'll do it the way you're actually going to, it's more likely to see it. I'll tell you the resistances of the 4 resistors, I'll tell you the 3 voltages, and then you'll figure out what the current is flowing through each of the branches. That's where we're heading. The last problem on the second test will be something like that. Spoiler. And as Porky Pig says, that's all folks.